Hello and welcome to this simple video about getting data to your CoCo quicker. We'll be talking specifically about bootstrapping DriveWire. Some of the earliest videos on this channel are all about DriveWire. I'm not going to be rehashing that, but just as a quick review, DriveWire allows your Mac or PC to act as storage for a fleet of virtual floppies that your CoCo can access. DriveWire is really three components. It's the DriveWire server, which runs on your Mac or PC. It's the client software that runs on your CoCo, called HDBDOS, and also it's the cable that connects the two of them. In fact, this gray part is my DriveWire cable, and the rest is a serial to USB adapter, because for some reason my PC didn't come with a serial port built in. What I really like about DriveWire is the fleet of virtual floppies that sits on your Mac or PC are the exact same format as you would load into an emulator. So when I do software for the CoCo, I'm mainly using emulators and the debuggers and the emulators and cross-assemblers. And only when I need to test on my actual CoCo do I fire it up and do I run DriveWire, and then I get to use the exact same virtual floppy file I had been using in the emulator, but now the CoCo is attached to it directly. When it comes to the DriveWire server software, you have a lot of choices. There's the DriveWire 3 app, there's the DriveWire 4 Java app, there's also a later build of the DriveWire 4 Java app, but for later versions of Java that don't require a system-wide installation of the Java runtime, and instead comes with its own Java runtime that it puts locally in the same directory. And there's also pyDriveWire, which I have not talked about in a previous video yet. This video is about the bootstrapping problem. I said earlier that you need to have client software, HDBDOS, running on your CoCo. But if DriveWire is the way that you transfer files to and from the CoCo, how do you get HDBDOS onto the CoCo in the first place because you don't have DriveWire running yet to do that? Well, the simplest answer is you just sing to your CoCo. The CoCo does have a built-in cassette port, and you can use that to save and load programs to cassette tape with this cable. And HDBDOS lives as a WAV file on the internet, so you can download it, play it through your laptop, use this same cable connecting your laptop to the CoCo, and now you have HDBDOS there. Only problem is, it's super slow. Now if you have a floppy drive, the next thing you can do the first time you load from audio is to take that HDBDOS file and then save it to a floppy. And then from that point on, you can just load HDBDOS from a floppy. That's a lot faster than loading from the audio file, but of course you need a floppy drive controller and a floppy drive to make that work. I've already gone over those procedures in previous videos. Now one other thing you could do is purchase a nice CoCo SDC or a FujiNet. They come with HDBDOS in the ROM, so as soon as you boot up your CoCo, it's there instantly. But there's one other way to do it, and that's using the pyDriveWire DLOAD server. DLOAD and DLOADM are commands that are built into the basic interpreter on the CoCo, but they are so elusive. There's like no documentation at all for these things in this whole manual. But if you look hard enough, you can find information about them, including several videos on the internet. pyDriveWire has a mode built in where it can act as a DLOAD server. And in fact, if you take a look at this video from its author Mikey, you can find all about how that works. So could we use the DLOADM command in Radio Shack Basic with a pyDriveWire DLOAD server and then use that to load HDBDOS into the CoCo? Basically, that becomes our bootstrap. The answer is yes. And we can even adjust the speed at which that transfer takes place. The DLOAD command accepts an extra parameter, 0 or 1, to tell it to run in either 300 baud or 1200 baud. But the pyDriveWire manual also talks about a poke you can use to get even faster speeds. That poke simply changes this value, which is then used to prime this register for a timing loop. As DLOAD receives information through the serial port, it uses that timing loop to make sure that it's accepting bits in the right speed. But can we do better than 2400 baud? Why, yes. The highest I could manage was 4800 baud. I tried a whole bunch of different values, but was never able to get it up to 9600. I even tried experimenting with the high-speed poke to see if I could use that with certain values, but it would never work. So here's a demo on how to get started. If you click the link in the description, you'll end up on the pyDriveWire GitHub repo. What I did is cloned the tip of master branch. If you go to the end of the page, you'll find a link to the full manual. I'm on Windows, so I went down into this section, and I specifically followed the instructions for PyPy. This is Python 2.7 based. There is an effort to convert pyDriveWire to work on Python 3, and I understand there is a build that is working well, but I was sticking just with the master branch. You download pip, you use pip to install PySerial, and then you're ready to run pyDriveWire. This is the command I used. It has it listening on my USB serial port, which is connected to the DriveWire cable, which is connected to the CoCo. And so right now it's running in pyDriveWire mode, which means it's listening for pyDriveWire commands. We want to switch it over to DLOAD mode. It can only be one or the other at a given time. So I'm going to configure it to look at CoCo files from this directory. This is where my HDBDOS file lives. And here's where I actually enable DLOAD mode, and you specify the baud rate there. So I'm going to do 4800. And finally, I'm going to turn translate off. I'm guessing this is useful when you're transferring basic programs, but since I'm just transferring binary files, I don't want it to change anything. On the CoCo side, you can see I'm running just extended color basic. There is no disk extended color basic here. I have my floppy drive controller unplugged, but this would work just as well if I had it plugged in. So if I did a dir, it wouldn't know what I was talking about. So here's the poke to configure it to do 4800 baud. At E6, we're going to use the value 7. And finally, we can now deload our HDBDOS. You'll notice I'm not going to do "0", I'm not going to do "1". Instead, I'm going to leave that blank so it makes use of what I poked. Now I'll execute what I just loaded. And you'll see that its startup screen has disk extend color basic and HDBDOS there. pyDriveWire has a browser-based GUI. So from here, I can load up any virtual file I want. I'll pick one of my games disks. So now if I type dir on the CoCo, not only will it... Whoops, I forgot something. I was going to say not only will it know what it means, but it will work. But I do have to put pyDriveWire into DriveWire mode. So I have to do DLOAD disable. And now I'm in pyDriveWire mode. Let's try this again. There we go. How about a little buzzard bait? You'll notice, by the way, it's going much faster. When we use DriveWire, it's better at using the serial port than the DLOAD command is. And so it's able to achieve much higher baud rates than even 4800. And so here are the timing results of all these different approaches to prime my CoCo with HDBDOS. And there's a link to my blog with the values that I used. Just a quick note that there appears to still be a bug with the DLOAD implementation in the most recent binary release, 0.6. So either use the source directly, or if there's been a new release since I've done this video, then maybe give that a try and that might work. And now, ladies and gentlemen, what is the fastest way to load HDBDOS? Who will come in first place? Oh, disk! Floppy disk comes in at first place at a mere 6 seconds and 23 SMPTE frames. Oh, there it is, 4800 baud at just over 22 seconds. Who will be next? Will the cassette transfer rate beat out DLOAD? Goodness no, 2400 baud still faster than cassette. And there is cassette beating out 1200 baud. Who is chugging along? It is the little baud that could. Anyway, that's all for now. Thanks for watching.